Question number 16. Boyle's temperature of a gas is the temperature at which a gas, first option, deviates very much from ideal behavior. Second option, shows ideal behavior over a considerable range of pressure. Number 3, gets liquefied rapidly by applying pressure. Number 4, gets boiled under a pressure of 1 atmosphere of surroundings. See, Boyle's temperature is given by Tb. It is the temperature at which real gas obeys ideal gas equation. That means behaves as an ideal gas over a considerable range of pressure. So, if you see a plot of Z versus P, there is one pressure. See, this shows lot of deviation. This shows relatively lesser deviation. So, this is at some temperature T1, this is at some other temperature T2. So, Tb is that temperature at which the value of Z for the gas will be close to 1 over a considerable range of pressure. So, the correct answer is option 2, that is shows ideal behavior over a considerable range of pressure. So, T2 is very close to Boyle's temperature in this particular case. Question number 17. In Van der Waals equation of real gases, A represents what? Look at the Van der Waals equation. P plus An square by V square into V minus Nb is equal to nRT. This is Van der Waals equation. The question is regarding A. What is A? First option, size of gas molecules. Second option, attractive forces between gas molecules. Third option, relative space occupied by gas molecules to the volume of container. Fourth option is collision frequency between the gas molecules which are at random motion. The correct answer is attractive forces between gas molecules. A is a measure of interparticle attractions which will cause decrease in the pressure exerted by the gas. So, the correct answer is second option. Question number 18. Carbon dioxide gas cannot be liquefied above 30.98 degree Celsius even if very high pressure is applied. This temperature is called dash of carbon dioxide. First option, inversion temperature. Second option, critical temperature. Third option, Boyle's temperature. And fourth option is boiling temperature. The correct answer is critical temperature. So, critical temperature is denoted by Tc. It is the temperature above which a gas cannot be liquefied by applying pressure. The temperature above which a gas cannot be liquefied by compression alone is called as its critical temperature. Every gas has its own characteristic critical temperature. So, for carbon dioxide, the value is very close to 31 degrees Celsius. Above 31, it is impossible to liquefy carbon dioxide by applying pressure, but below 31, it is possible. Answer is second option. Question 19. Solution drops as small spheres from the tip of the burette. This is illustrated by one of the following properties of liquids. First option, viscosity. Second option, free flow. Third option, surface tension. Fourth option is vapor pressure. The answer is surface tension. Water droplets are spherical. The spherical nature of water droplets has something to do with surface tension. You know, spheres occupy minimum surface area. That's why water droplets tend to remain spherical. So, the answer is third option, surface tension. Question number 20. Select the correct statement about the vapor pressure of a given liquid at a given temperature. First option, it increases with increase in pressure on liquid vapor. Second option, it decreases if the surface area of the liquid is decreased. Third option, it does not vary with change in atmospheric pressure. Fourth option, it remains constant. See, look at the question once again. Select the correct statement about the vapor pressure of a given liquid at a given temperature. If temperature is not being changed, what happens to the vapor pressure of a liquid when external pressure is changed? Actually, there is no change in the vapor pressure. Vapor pressure of a liquid does not depend upon external pressure. It depends on temperature only. So, the correct answer for this question is fourth option. It remains constant. Question number 21. Which of the following is true about the effect of rise in temperature on surface tension and viscosity of liquid. The question is regarding what happens to the surface tension and viscosity of a liquid if its temperature is changed. First option, surface tension increases and viscosity decreases. Second option, surface tension decreases and viscosity increases. Third option, both surface tension and viscosity increase. Fourth option, both surface tension and viscosity decrease. This is the correct answer. Fourth option is the correct answer. Due to increase in temperature of the liquid, its surface tension decreases, its viscosity also decreases. Question number 22. Which of the following statements are not correct? A. Poise is the unit of viscosity. This is a correct statement. Poise is the unit of viscosity. B option. Viscosity of a liquid increases with increase in temperature. This is an incorrect statement. Viscosity decreases with increase in temperature. Ethylene glycol has more viscosity than ethanol. This is a correct statement. Actually, ethylene glycol, you can see ethylene glycol is ethane 1,2-diol. This is ethylene glycol. Whereas ethanol has only one OH group per molecule. Ethylene glycol has two OH groups per molecule. So this can form more extensive hydrogen bonding, and that's why its viscosity will be more. So ethylene glycol has more viscosity due to greater extent of hydrogen bonding. D option is when water is flowing through a pipe, its velocity in the middle of column is lesser than that of the surface due to viscosity. Actually, if this is a pipe and water is flowing, then the viscosity is more in the center, middle of the column than near the surface. So the correct answer for this question is B and D are incorrect statements. Viscosity of liquid increases with increase in temperature. This is incorrect. Actually, it decreases with increase in temperature. Statement D is when water is flowing through a pipe, the velocity of middle of the column is lesser. Actually, middle of the column, the velocity is more. Question number 22, the correct answer is third option. Question number 23, which of the following statements about vapor pressure of liquids are true? A. Liquids of higher vapor pressure boil at lower temperature. A given liquid has higher boiling point at lower pressures. Vapor pressure of a liquid increases with increase in temperature. D option. A given liquid has lower vapor pressure when taken in a smaller vessel at a constant temperature. Actually, vapor pressure has nothing to do with the size of the vessel, and also remember that vapor pressure does not depend upon external pressure, and also remember this, I told you it does not depend upon the size of the vessel. Whether the liquid, same liquid, if it is present in vessels of two different sizes at same temperature, then they exert same vapor pressure. Also remember that when vapor pressure of liquid becomes equal to external pressure, then the liquid boils. Look at this statement, statement B, a given liquid has higher boiling point at lower pressure. Actually, at lower external pressure, the boiling point of liquid will be lesser. And also look at the statement A, liquids of higher vapor pressure boil at lower temperature. This is a correct statement. If the vapor pressure of liquid is more, then it will match with external pressure at a lower temperature. So its boiling point will be low. So the correct answer is A and C. Third option. Statement A and C are true statements. Question number 24. Assertion is viscosity of a liquid increases with rise in temperature. Actually, viscosity decreases with rise in temperature. This is an incorrect statement. Look at reason. The intermolecular attractions decrease with rise in temperature due to increase of kinetic energy. This is a fact. Actually, when you increase the temperature of a liquid, the molecules of liquid have higher kinetic energy, they move faster, the attractions will be decreased. So you can say the correct answer is fourth option. A is not true, but R is true. Fourth option is the correct answer. Question number 25. Assertion. The pressure exerted by real gas is always less than that exerted by ideal gas. This is true. Actually, what happens, pressure exerted by gas is due to collision of gas molecules with the walls of the container. If there are interparticle attractions, then the impact of collisions will be less due to attraction. So assertion is correct statement. Look at reason. Molecular velocity is decreased due to intermolecular attraction. This is also a fact. So due to intermolecular attractions, the molecular velocity will be less. So the impact of collisions will be less. So the correct answer is first option. Both A and R are true are the correct explanation of A. So the correct answer is first option. Question number 26. The assertion is RMS velocity of SO2 gas molecule is half that of methane molecule at a given temperature. RMS velocity depends upon molecular mass. If you see the formula, C is equal to root over 3 RT by M. So if you compare SO2 and methane, this is 64, this is 16, this is 4 times. If you take the square root, this becomes double. So RMS velocity of methane will be twice that of sulfur dioxide. So assertion is correct because SO2 has half of the RMS velocity of methane. Second, reasons. Molecular velocities of gas molecules are directly proportional to the square roots of their absolute temperature. Molecular velocity of gas molecules is directly proportional to the square root of their absolute temperatures. This is also correct. You can see C is proportional to square root of T. So the correct answer for this question is second option. Both A and R are true. R is not the correct explanation of A. Question number 27. In the list 1 you have vapor pressure of liquid, RMS velocity of gas molecules, kinetic energy of gas, viscosity of liquid. In the list 2 you have the various conditions. Let's see. Vapor pressure, you can match it with the let's look at the answer and try to justify this. A, vapor pressure. The correct answer is second option. A is being matched with first and second statement. It increases with increase in temperature. Increases with temperature. This is true, yeah. And then depends on intermolecular attractions. It also depends on intermolecular attractions. So A can be matched with both these first and second statement, and then B is matched with only one. Let's see what is B. RMS velocity of gas molecule. It is being matched with only first option in the list, increases with rise in temperature. That's a fact. RMS velocity increases with increase in temperature. Then C, kinetic energy of gas. It is being matched with two options, increases with rise in temperature. That's true. Ke is proportional to temperature, and it also depends on intermolecular attractions, because due to intermolecular attractions molecular speed will be less. And then viscosity of liquid. Viscosity of liquid, this is being matched with third and fourth. Greater if the molecules of compound are heavier, that's true. Decreases with rise in temperature, this is also true. So the correct answer is second option. Viscosity it decreases with rise in temperature. If you increase temperature, viscosity, because the molecular speed increases and intermolecular attractions will be less, viscosity will be less. So the correct answer is second option. Question number 28. In the list 1 you are showing dependency of various state properties of gas, and in the list 2 you have appropriate gas law. Let's try to match. Pressure of gas depends on the volume of the container. This is showing relationship between pressure and volume, so this A should be matched with to Boyle's law. Yes. Second option, B option. Molecules have greater velocity at higher temperature. Molecules have greater velocity at higher temperature. So this should be matched with Graham's law, because if the temperature is high, the molecules move faster and they spread faster. And then volume of gas is directly proportional to its absolute temperature. This is nothing but Charles' law. And then fourth option, partial pressures are in the ratio of moles of gases. Dalton's law deals with this. According to Dalton's law, partial pressure of a gas is proportional to its mole fraction in the mixture of gases. So the correct answer is third option. Question number 29. Kinetic energy of gas molecule is 0 at which one of the following temperature? At absolute 0, the mobility of molecules will be restricted, its kinetic energy becomes 0. So the correct answer, absolute 0, is minus 273 degrees Celsius. So the correct answer is third option. The question is the ratio between RMS velocities of helium at 100 Kelvin and methane at 400 Kelvin. See, the relationship is like this. C is equal to root over 3 RT by M. So we want to know the ratio C helium and C methane. Methane, molecular formula of methane is 4. Molecular weight of methane is 16. Molecular weight of helium is, atomic weight of helium is 4. So this is 4 times, and the temperature, you can see temperature of helium given is 100 Kelvin, and temperature of methane is also, it's 400 Kelvin. This is 4 times, and molecular weight is 4 times less. So this lesser molecular mass tends to make it more faster, low temperature tends to make it slow. So this is 4 times less, this is 4 times more. So you can say that their ratio of their RMS velocities will be 1:1. You can as well do like this: 3R T helium by M helium is to 3R T methane M methane. The square root gets cancelled, 3R also gets cancelled. T helium by M helium is equal to T methane by M methane. Now what do you substitute for M methane? You substitute 16, here you substitute 4, and here you put 100, and here you put 400. So that becomes 1:1 ratio. With this, we have come to an end this discussion of questions on gases and liquid state. Thank you very much.